Good morning, one and all present here today. The Asian College of Journalism, in collaboration with the Center of Study for Science, Technology and Policy, has organized today's colloquium on science, technology, policy and society. I am Aditi, your host for today, and before starting with today's session, I would like to request you all to kindly switch off your mobile phones or put it on silent mode. To begin with, I would invite Mr. Shashi Kumar, Chairman of the Asian College of Journalism and the Media Development Foundation, to say a few words about the colloquium.
Thank you, Aditi, and good morning, students, our valued guests, experts who have come to participate in the seminar, in the colloquium, and others who have, in response to our invitation, joined us here this morning. The subject of this colloquium is one that is, shall we say, conspicuous largely by its absence in the news media today. Science, more so than technology. I think technology gets a fair representation for marginal reasons, that it has to do with the iPhone and it has to do with gizmos and devices that make living and communication easier. But science has kind of tended to be marginalized in the media, at least in the news media, in the mainstream news media. And that, I think, makes the news media that much weaker because the importance of science, particularly at a time when we are living in a world of what I would characterize as increasingly narrow identity politics, the importance of the universalizing impact of science is that much more significant and should be getting better play, better traction in the media. When you say science, of course, there is science, there is a scientist, and there is scientific thinking. I'm not a scientist. Most of those who will be speaking to you today are scientists who have been through the rigorous discipline of science, the methodology of science. But I think being scientific and being a scientist are, of course, two different things. All of us, I think, are required as rational, logical thinking human beings to be scientific in our approach. In fact, in the immediate post-independence period of India, there was considerable importance given to the idea of scientific temper. In fact, that was a term that one heard often, the scientific temper. And the scientific, I think, men of science or women of science, scientific persona, were public intellectuals. They interacted more with society than I think happens today. And that's true to a large extent of many academic disciplines. Today, unfortunately, even on developments in science, we find media persons rushing to Godmen for their response about what is the view on what has just happened. That's just an example. Of course, politicians are ubiquitous and they have their view on everything, so they naturally respond to events as well. So this is really an attempt to initiate some of us. I think many of us may not have been as alive in terms of our sensibility and in terms of interaction to our environment, in terms of scientific developments and what science means. It's partly to do that and partly to bring us up abreast of some of the cutting-edge science that's going on, and to hopefully, when we leave at the end of the day, we'll have a more open, perhaps at the worst, more open, at the best, a very enthusiastic, shall we say, new response to the idea of science and being scientific in our approach. Science, of course, science, I'm not a scientist, but it's my sense that science is more enduring than technology in some sense, because in technology we speak about the rate of obsolescence being very high in technology. And in communication, in the area of media, we know that very well. Even the smartphone that you use keeps changing every 6 months or 8 months because there are newer attributes or newer features that come in. And in like ways, most of the gadgets, utilitarian gadgets that we pass off as technology that makes our lives better, the rate of obsolescence is very high. In science, arguably, it's not so. Science is more enduring, although science is an incremental effort. It's an effort at perhaps discovering things that we didn't know, or improving on things that we know, or finding out the logic of the reason why, more about things that are manifest and palpable, but we haven't fully explained. Perhaps like the Big Bang, for instance, even now. Have we fully parsed the Big Bang? Have we fully parsed black holes and the physics that is at the core of it? Or have we fully reconciled quantum theory with Einstein's theory of relativity fully? So these are some of the interesting ideas, and I'm of course recalling from my study of, from popular readings of science. One of my favorites used to be Roger Penrose and his The Emperor's New Mind. That is way back in the 1990s. But these questions were valid even at that time. And today, of course, for us as journalists, as media people, the science that we interact with tends to be the very exciting new category of artificial intelligence, if you like, or machine learning. And of course, some of you know, as far back as 1950, that was a Turing test, which kind of tried to look at human capability versus the capability of the computer and have a comparative or a competitive analysis of the two. And where are we on this? Has the Descartesian notion of I think that I am, Descartes' famous dualism theory, that there is mind stuff and then there's other material stuff. I think, so has that been replaced to some extent because of the huge leaps that are made by artificial intelligence and machine learning, by what Rimbaud, the French poet Rimbaud, presciently called, it's no longer I think, it's it thinks me. So is the computer second-guessing us, or are we second-guessing the computer, is probably one of the things that we may be discussing in the future. So these are all exciting areas. They are also areas of science fiction at some levels. I think in the course of the day, there may be inputs that allow us to elaborate on some of these in our own minds and pursue perhaps some strands of thought that emerge in the course of the colloquium today. I'll end by just talking about how science fiction itself is such a fascinating area, which at one time we thought was doing injustice to science, but I think we've learned with time that science fiction is perhaps a kind of quantum leap, which sometimes is very valuable. You make a quantum leap and then you cover the ground in between through rigorous, and that's the job of rigorous scientists, of course. Quantum leapers are science fictional in some ways. Some of them may be scientists as well. I think after the Cold War, the emergence of a new kind of cinema, for instance, where you have teleportation and so on, which was science fictional, are now being discussed as very likely, in the future, in terms of already you are able to be seen simultaneously in many places. It's a form of teleportation of the human self. We know that in one election earlier, the Prime Modi was seen simultaneously in many places, because there were virtual images of him and things like that. So science is making huge strides in ever so many ways. And I think after the Cold War, what we saw was the labs which were working with special effects in the area of science towards, which was an input in the Cold War, were found themselves redundant. And that is how you find robotics in cinema emerging in a big way. That's how Steven Spielberg or George Lucas, people like that, a new crop of directors, began to use special effects and began to create mega stars who were not physical. The characters of Star Wars, or some of them were physical, but some of them were robotics. And that is how you get E.T. and characters like that, aliens, which were created out of this technology. And these were meant to be low-budget cinemas, but of course they soon became far more expensive than even actual stars, making films, meaning that they became a huge proposition. And there was branding, there was co-branding of merchandising of all the characters that have emerged in that whole scheme of science fictional cinema. So with these few words, I hope, I'm very excited about this day. I hope all of you are. I'd like to just finally a word of caution. We shouldn't be dismissive of science because science is even more important today. Is science pitted against spirituality? Is science pitted against religion? Can a scientist be religious? Does that mean an unscientific temper? These are some of the thoughts too that you might find clues to, perhaps not definitive kind of solutions in the course of our discussion today. But primarily, I think to ground it in your practice of journalism as media practitioners, how does a scientific approach, I think, will make you that much better, will make you a cut above the rest, particularly at a time when no one has the patience or the wherewithal or the resources, shall we say, to develop this whole scientific part of one's identity. With these few words, I'd like also to thank very much C-STEP and Jaya Sundi and the chairperson of C-STEP, Dr. Dipankar Banerjee, who happens to be an old friend of mine. When he was in the neighboring campus in IIT in the 1970s or 80s, 70s actually, I used to visit the place often and we became good friends, although academically we had very little in common. But so I'm very happy to see him back here today. And it's his initiative at a random conversation. He let drop the idea that why don't you have a colloquium and we could get C-STEP to help, and that's how this. So I'm very, very grateful to both Jaya Sundi and Dr. Dipankar Banerjee, and I wish you a very rich, useful, and purposive colloquium through the day. Thank you very much.
Thank you, sir. Now I would like to invite Dr. Jaya Sundi, the Executive Director at the Center of Study for Science, Technology and Policy, to come up and give us an introduction on C-STEP.
Thank you. Good morning. Good to see students, and thank you, Shashi, for that warm welcome. It's great to be here today. I hope the energy is high in the room this morning. We are very excited. The Center for Study of Science, Technology and Policy is a think tank. We are based out of Bangalore, and our mission is to enrich policy making with innovative approaches using science and technology for a sustainable, secure, and inclusive society. What does that really mean from a practical point of view? As of today, we are trying to address what we would call the grand challenges. And the grand challenges are, one of them is on the clean energy transition. How are we going to get to a clean energy future? I think all of you must be reading it in the news today. Everyone is worried about global warming. And in the immediate, the question becomes that we need to cut down on our CO2 emissions or our greenhouse gas emissions. How do we go about doing that? For a country like India, it's a big challenge because we have not reached the developed status yet. How do you tell somebody that, no, you will not burn fossil fuels when that person is trying to struggle and make ends meet on a day-to-day basis? So that's the first challenge on clean energy. The second one is something that we all experience, is air pollution. And that is something that we are very keen to work on, is clean air for all. How do we get there? And the third challenge that we will all face is an extension of the first challenge, is that how do we get from the issues on global warming, how do we deal with that in the coming few decades? What are the choices that we will have as a country? Many of us may not be there, but many of you will continue to be there. And how are we going to, what do we need to be doing today so that we can handle that future tomorrow? And this is what we call sustainable, secure futures. Because clearly we want to have sustainability in our lives, but we also want that security, and we want to make sure that we have a decent quality of life for all. So these are the three grand challenges that we've been working on. As an organization, we have about 100 people. We are based out of Bangalore and have an office in New Delhi. And one of the approaches that we are doing is to make sure that we collaborate with as many entities as possible, because we know that we will not be able to achieve these or address these grand challenges without collaborating with all. And this is where you come into place. We have come to realize that in an ecosystem approach, we have to engage with the people. We have to engage with populations. And what better way to do it than to do it through journalism? Because journalists have a way to reach out to a much larger audience than we think of. And that is where the idea behind this particular colloquium comes into place, is that how do we get journalists, some of you who have been trained in the sciences, but some of you who haven't. But at the same time, it is important to understand the impact science and technology has on society. And that is why we have put together a series of talks for today, so that you get a flavor of what these subjects are all about. You are not going to turn experts. You're not supposed to be the experts. You are the people who are supposed to be asking the right questions to the experts, so that you can be able to communicate the key ideas behind what is going on in the sciences or in the technology to the common people, so that they understand the importance or the value of what is going on in the sciences. Scientists typically are spending a lot of their time trying to understand the key aspects of the science, and they are not so worried about how is society going to react to that. But we do need people to start thinking about those things. And with that purpose, we have put together the program today. We would like to have had a lot more variety, but we realize that there's only so much that you will be able to absorb in a single day. And with that, I would like to say that this colloquium is not an end in itself, but it is the beginning. And I would say it's a beginning in the journey that we would like to have on the role of science and technology in society, where our society starts to understand the value of science and technology, and also weighs in on some of the more nuanced aspects related to science and technology, all towards what at C-STEP we like to think about as a decent quality of life. I think that is what we want for all. It is not about wanting to have the big 4-bedroom bungalow with 4-car garage. I don't think that is something that we should aspire to for everyone in society if we want everyone to be there. We're talking about an equitable society. So I think the notion of a decent quality of life is what we need to have for all. And science and technology has shown to provide that for most people in the developed world. The question becomes, what do we need for people in India? So with that, and with the few words, I would like to say, let's make impact, let's collaborate, and let's get the word out on science and technology. So for once again, thank you all for being here, and welcome to this colloquium. Look forward to a productive day, I think, of discussions and questions regarding various aspects related to science and technology. So thank you once again, and welcome all.
Thank you very much, sir. Up next, we have Dr. Jessica Marshall, Executive Editor for Life Sciences at the Chemical and Engineering News. Dr. Marshall has worked as a freelance science journalist for almost a decade. She holds a BSc in Chemical Engineering from Princeton University and an MS and a PhD in Chemical Engineering from the University of California, Berkeley. She also has a certificate in Science Communication from the University of California. She'll be joining us virtually today. Welcome, ma'am.
Welcome, or thank you, rather. Thank you for having me today. I'm very honored to be a part of your symposium and among fellow journalists. And I'm sorry not to be there in person to meet you all. I have just a few minutes to speak with you, so I will try to highlight a couple of things. I'm going to actually just share my screen here. I put a couple of these things in slide format, so might as well show them to you. So let's see. Oop. All right, let's see if this will work now. Can I advance the screen is my question. There we go. Yes. So first of all, never has it been more clear the importance of science in journalism. The COVID pandemic was a years-long, nonstop science story. I don't think anyone would have imagined 5 years ago that members of the public would be talking about PCR tests or virus evolution, how particles move in air in the detailed ways that we all do now. And even before that, climate change was, and it still very much is, the science story of our time. Air and water pollution are global and local issues. Whether you report for a global news outlet or for a small community paper, scientific issues, especially around environment and health, are crucial to people's lives. Science stories also have the potential to uplift people, to delight them, and to capture their sense of wonder. People love to read about animal behaviors that no one has understood before, about a new dinosaur or a robot, or findings in deep space. Science is driven by discovery, and for that reason, news is baked into the scientific method. In fact, I like to point out to people when I talk to scientists about journalism or journalists about science, that science and journalism have a lot in common. Scientists and journalists have a lot in common. Both are investigators, both are driven by a quest for truth, both aim for objectivity in what they do based on identifying evidence. And both are detail-oriented. Both understand that trust in what they produce depends on accuracy, on being oriented to the details. And I truly believe that both are fundamentally idealistic professions, driven by service. So there's much one could say about how to cover science as a journalist. How to decide what's newsworthy, how to read a scientific paper. I'm sure you'll dig into various aspects of things more today. But I thought I would just pick three things that came to my mind that I think are useful to think about as a journalist, thinking about how to cover science. And these apply whether you're thinking about a career as a science journalist, focusing specifically on science, or just picking up a science story among the other things that you cover. The first is the thing that is the first rule of journalism and in any beat, which is to think of your audience, that you work for your audience. So, in the context of science, what do they care about? What do they know already? This can help you think about what your starting point is for presenting the science you might be writing about. Are there concepts that you need to explain? Are there things your audience already knows that you can build from in explaining whatever scientific finding you might be writing about? But I think this is very important. Do not talk down to your audience. Assume your reader is smart, but may not know the same things you do. A second point is that scientists are wonderful characters, they're wonderful sources, and they usually love to talk about what they do. And this is a wonderful aspect of reporting on science. They're typically very open and frank, but sometimes researchers are so used to talking to other experts that they might not be accustomed to talking about their work in the way that you need them to for your audience's sake. So this is something to pay attention to in how you ask questions and where you follow up. Often people say, my audience won't know that word. Can you tell me that in another way? Your work, in some sense, when writing about science, is translation. And this brings me to the final small point. Well, it's not a small point; it's a big point. But the final of my 3 points today, which is jargon and terminology. This is a really big issue, I think, in writing about science. It's not unique to science. There's jargon in writing about business. There's jargon in writing about sports. But just as language matters in journalism, language matters very much in science. Certain words have very specific meanings to researchers, so it's important to pay attention to what those meanings are. Here are some examples in this word cloud. I took this from a blog post written by the science journalist Ed Yong. and his point here is it's a shame that so much material could be opened up to a much broader audience with just a few tweaks to word choice and sentence construction. Right. In general, science is awash in jargony and jargony terms, and learning to avoid those, to translate those, to choose simpler terms, to decide if you can leave them out, I think is a crucial aspect of making science accessible to a public audience. As Ed writes here in this little quote I put in the corner, I write about the shapes of living things, but not the morphology of organisms. So I think that's just one other thing that maybe in some way sets apart writing about science from other things, is the importance of paying attention to these words and trying to translate in accurate ways, but ways that meet your audience where they are. So I'll just stop here. I have some resources I've put here for those who might be interested in additional information about science writing, science journalism. Here's a couple of starting points. And I don't know if there's time for questions. I know you have a tight schedule today, but I'd be happy to take them if so. Thank you very much once again for having me. I think I can hear that.
So, Akshay, I have one question. You talked about using jargons in science reporting, but what we have been taught is that we need to use simpler language. So, how does the two things combine with?
To the first question, I'm sorry. What I meant by being aware of jargon is actually what you said, which is to use simple language. You may need to understand the jargon as the reporter, but then to try to translate that jargon into simpler terminology that your audience will understand. And why do I assume our audience is smart? I think that it's never going to be good communication if you're inherently assuming that the people you're talking with aren't smart, right? I think that that we that my point is to assume that they maybe don't have the same knowledge, but that they are inherently intelligent, and or capable of understanding what you are trying to communicate to them. So I guess what that means in a nutshell is that people don't like to be talked down to, right? And so perhaps when explaining scientific concepts, it's something to keep in mind. Yes. Yeah, that can be a challenge, right? And it maybe feels more daunting, if someone asked me to write an article next week about a cricket match, I would have to ask myself this question too, where to start? I don't know. So I think it's probably a combination of things. Sometimes you can find information online that you can read for background, knowing, of course, that you have to be careful about the accuracy of the sources you're using. Wikipedia can be a starting point to point you to reliable sources, but not one to use. Also, it really just helps to call experts, maybe who have a little bit of time, who would be willing to explain things to you that at a really fundamental level. And I'm certainly indebted to people who have taken the time to do that for me at times when I've had new areas that I've been trying to understand and to report. And I think people are usually very excited to explain what they know about to people. I think that when you can be respectful of other people's time by doing as much, background reading before you come in to an interview as possible, that's helpful. Yeah, I sometimes tell people that I'm a professional Googler, because I think when there's something I don't understand, I just start by Googling around and educating myself in different ways, and testing the sources that I am reading, and trying to begin to make sense, and then from there, being ready to interview people.
Well, I think that's it. Thank you so much, ma'am, for talking to us despite the time difference. It's almost bedtime there, but you still agreed to join with us for the colloquium. Thank you so very much for that. Up next, we'll move on to our first session for the day, Introduction to Science and Technology. I would like to invite on stage Mr. Sashi Kumar, Chairman ACJ, who will be chairing this session along with the speakers for this session, Dr. Dipankar Banerjee, Professor at the Indian Institute of Science, Bengaluru, and Dr. Aparajit Ramnath, Associate Professor at the Humanities and Language Division, School of Arts and Science, Ahmedabad University.
So the session that we are getting into it's not up on the board yet, okay. But let me introduce the speakers to you. Dr. Dipankar Banerjee, he graduated from the Indian Institute of Technology, Madras in 1974, obtained his doctoral degree from the Indian Institute of Science, IISc, in 1979. He has been the director of the Defense Metallurgical Research Laboratory, DMRL, and then chief controller of research and development at the Defense Research and Development Organization, DRDO, providing leadership of critical materials and aeronautics program. Since 2010, Professor Banerjee has been on the faculty of the Department of Materials Engineering at the Indian Institute of Science. Professor Banerjee is a fellow of the Indian Academy of Sciences and the Indian National Academy of Engineering. He has been on the board of governors of IIT Madras. For his contribution to engineering sciences, Professor Banerjee was awarded the very prestigious Shanti Swarup Bhatnagar Prize for Science and Technology in 1993. And the DRDO, the Defense Research Development Organization, has conferred upon Dr. Banerjee its Lifetime Achievement Award. Apart from that, he is also a recipient of the Padma Shri from the Government of India. Dr. Dipankar Banerjee will be speaking first.
Okay, good morning to all of you, and thank you, Sashi, for the introduction, but thank you also for responding so quickly to this conversation that you mentioned that we had just a few months back, I think. So I also remember that you had invited me to talk in 2011, so I'm back here after more than 10 years, certainly older, not sure much wiser, but there it is. Okay. So you've heard something about why this colloquium has been organized, and let me add my 2 bits worth as we go along. So first of all, an enormous commitment of governments to science and technology. So there is President Obama talking about funding in research and development, and the former Prime Minister Manmohan Singh talking about societal aspects of science. And this is a statement, I'm sorry, I've got to get used to this. This is a statement by someone that you're familiar with, Professor Ramakrishnan, Nobel laureate. Scientists have an ivory tower mentality, and we've just touched upon that right now. And they don't go out and engage with people. So given that, what I'm going to try and do over the next 20 or 25 minutes is to go over the nature of science and technology as I understand it, something about our community, something about science, technology, and its social and economic context, and the speaker following is going to go into that in much greater detail, and a little bit about science and technology in India. So this is what's going, and the idea is to lay a framework for the presentations that you will hear through the course of the day, and so I hope you'll find this introduction useful. So when did science start historically? And you can take your pick. You can talk about the Indus Valley civilization or astronomy or the discovery of the wheel or the discovery of zero, the mathematics of zero. But the word scientist itself is relatively recent and coined from the Latin the word scientia, meaning knowledge, in something like the 19th century. So at its most exalted, and Sashi touched upon this, there is a commonality between magic, science, and religion, although we tend to think of these things as very disparate. And the commonality is that they all address the entire conception of ourselves and our place in the universe and how we shape our lives. So how does science work? All of us practice each of these things in slightly different ways, depending upon our bent of mind and our profession. But all of us do this, parts of all of this. And so how does science work? Well, the traditional view of science, and again, we've talked about a scientific temper. The traditional view of science is that we observe nature, propose a modest law that generalizes an observed pattern. But a more rigorous definition of science, and this is extremely important, is that essentially what we're doing is examining a number of competing conjectures. We then develop a theory which is not necessarily more true, but more fit. And we understand throughout this process that this theory that we propose can always be refuted in the future. And the important message I want you to take away from this is that there are no absolute truths in science. And so then we have a community, and we have a self-regulating community of researchers, and Dr. Marshall talked about the similarity with journalism, and essentially this common ethos, a sharing of information, a skepticism of results, and a strong belief in the pursuit of truth, and importantly, peer scrutiny. But this wonderful book, Thomas Kuhn talking about the structure of scientific revolutions, pointed out that there's always a dynamic between the ways ideas challenge the environment and the way environment shapes ideas. And so, as in everything else, you should be aware that in scientific matters, self-interest matters, social values matter, and sources of funding matter. And yet, science progresses, and this is because it's fundamentally based on these principles that are enunciated here. I'm going to talk about the notion of absolute truth with two examples. And again, Sashi touched upon this. So everything that you do, all the functions that you utilize in the world around you are based on the laws of the laws that Sir Isaac Newton described, a theory of how bodies moved in space and time. And in his world, in his universe, time and space are distinct entities. And the universe had existed forever in an unchanging state, a static universe. And yet, when Einstein came along, he described that this was not necessarily true for objects that move relative to each other at speeds approaching the speed of light. And as a consequence, there's a warping of space-time due to mass and energy in space. And now it is not time and space that are absolute. Time and space are linked together. The laws of gravitation emerge as a consequence of space-time. But the speed of light is absolute. The important consequence of relativity comes through the work of Penrose and Hawking. And again, Sashi mentioned Penrose. And that is now, instead of a static, unchanging universe, the universe must have a beginning about 14 billion years ago and is expanding. But then comes quantum mechanics. This is still a deterministic universe. from Newton and Einstein, in the sense that if you have laws of physics, you can predict what's going to happen in the future. But now comes quantum mechanics and this explosion of physics in the 1920s. And at what quantum mechanics suggests is that if you have a very small particles, such as atoms, you can't quantitatively predict their location and their velocity with certainty at the same time. And therefore, the universe is no longer completely deterministic. And therefore, one can certainly not predict the future events exactly, but only in a probabilistic manner, nor do we know what happened at the beginning of the origin of the universe with any great degree of certainty. And therefore, the holy grail of modern physics for decades, a theory that combines quantum mechanics and Einstein's relativity. And should that ever happen, our views of the universe may completely change. There are no absolute truths in science. There is a constantly evolving idea of what we are and what we are about. And so also for life. If in 200 AD the Earth was the center of the universe and there's plenty of space for heaven and hell around the Earth, we also have changed our notion of man as being the central portion of life forms. And so now we understand that man is only a part of an infinite set of life forms. And there is a continuous evolution and a connectivity and an intricate relationship between every life form that there is. So look, for example, at this beautiful image of the embryo. Genes express themselves in proteins. Proteins differentiate at different parts of the embryo. And as proteins translate themselves into the functions of cells, you can slowly see the emerging structure of the embryo. Why do I show this? Simply to point out that the similarities between mice and human genes, and apes and monkeys and rabbits, for that matter, range from about 70 to 90%, with an average of 85% similarity, but a lot of variation from gene to gene. Man is no longer at the center of the universe. We are not too different from the ant on the floor, on the mice, or the monkey in that sense. And really, that's the reason people study monkeys and rabbits in experiments. Okay. But all of us, most of the time, and most of us, some of the time, are really not concerned about how the universe began, nor are we concerned about our relationship with other living forms. The time frames are too large, the concept's abstract, and this is where technology comes in. So technology always begins as craft. And here's my little example of this. The casting of these beautiful Chola bronzes described very precisely, and this is available at the Lalit Kala Academy here, and the expression of this casting technology in terms of philosophy and philosophy in terms of the casting technology. But what I want to point out to you that the application of the physics, chemistry, and the mathematics and the engineering of the casting process is today used in making these components, these very high temperature metal components that drive your jet engine. This is how technology evolves. Generally as a craft, it's intersection with our understanding and knowledge of things and to the most precise applications that you can think of. There is, of course, an intimate relationship between technology and war. Much of the technologies that you use today were actually developed in the battlefield context. And here's the anomaly. This is Einstein's famous relationship between energy and mass, which lies at the core of the nuclear processes that drive the atom bomb. And therefore, you have to think about the neutrality of science and technology and the notion of ethics and morality with every aspect of science and technology. And these perceptions can be anomalous and very confusing. And so here, for example, is technology in operation and action sometimes, And all of these incidents are taken from Nature, a very important, a very well-known scientific journal. And if you look at the set of experiments, you would hardly think that they were not carried out in Hitler's Germany, but in the United States over fairly recent times, all to understand, if you will, the action of mustard on mama. Okay? So technology in action sometimes. I want to emphasize to you that there is no technology that grows overnight. If you trace the antecedents of technology, you will find that there is a gradual improvement in capability as the years go by. So I've chosen for you two examples, which our speakers will talk about in more detail in the afternoon. And essentially, I want to talk about genomics here. So the principles of inheritance, the way in which traits are passed from one generation to the next, were actually developed by Gregor Mendel in 1865. And it's interesting that he did this using pea plant breeding. Okay? Look at this is fascinating. Someone studying peas discovers a principle of inheritance that governs all our lives. This is what today would be called blue sky research by governments that can't look beyond their immediate nose. But these principles of inheritance were discovered without any knowledge of genetics. Soon after, the identification of DNA, the constituent of the gene, was discovered in 1871, the structure of DNA in 1953, the translation of the genetic code into creating proteins in 1962, and then Fred Sanger in 1977 developed techniques to sequence the complete genome. The genome is the entire DNA content that is present within one cell of an organism. And finally, in 2003, the human genome had been indexed. The impact on genomics, this entire book of life, if you will, starting from the word, the arrangement of words into sentences, sentences into chapters and so on, leading to what I'd call the book of life, the human functions in general, the impact of disease treatments are likely to be enormous. And I hope we learn more about it this afternoon. But together with it comes the ethics of gene manipulation, and all of you should be aware of these issues, and then related healthcare costs. Okay? The other example I have is, again, something which Sashi talked about, and the idea of artificial intelligence. And again, I simply want to point out this. I don't want to describe the pros and cons of AI here, but I do want to point out that artificial intelligence today is actually dependent on the growth of three very interrelated strands that have interacted with each other. The development of communication technologies, starting with telegraphy in 1835, fiber optic communication, wireless telegraphy, and cellular communication, which continues in terms of the volume of data that can be transferred and the speed at which it can be transferred. Computers, starting with the abacus in 200 BC, supercomputers in 1964, linked to the development of the transistor and integrated circuits, and the PC, and this is obviously still evolving, and of course software-related aspects and the internet and the web. And remember, I talked about the relationship of the battlefield to technology, and this was of course developed by the Defense Advanced, or funded, the development of this was funded by the Defense Advanced Research, DARPA in the United States. And simultaneously, all of this, thoughts of how machines can mimic human intelligence, Sashi also talked about Alan Turing in his introductory talk, and the more recent developments of what we call foundation models, essentially deep learning algorithms that are trained with extremely high data sets obtained from the public internet. And so you have today's artificial intelligence. What is its impact going to be in the world in general and in our country is something that all of us have to understand much better. But technology, and I've given you some aspects of technology, lies at the very heart of historical change. And it does so because significant societal and intellectual change is caused by changes in the productive forces of economy. And so we must understand this relationship well. We have science, an understanding of the universe, technology as an application or body of knowledge by which we control our environment, remember magic and alchemy, and then engineering, a systematic and iterative approach to designing a product or process, and these are often used simultaneously. But all of these put together are translated into production of goods and services, and in that translation, or underlying that translation, lies the demand for those goods, the factors of production, capital and labor, land, infrastructure policy, and more recently, sustainability, environment effects, and we're going to talk about that as well a little later. And then, therefore, of course, the translation of this background of knowledge to the production of goods and services depends on political, geographical, social, and the environmental ecosystem. So politicians who come to scientists and say work for society, there is a kernel of truth in that advice, but they forget about the fact that the translation of these things into actual delivery depends on many of these factors. You don't need science to translate existing technology to rural electrification, or provide safe drinking water, or provide health care. What you need is a management of these factors. So all of this is interrelated in ways that we must understand and define. And so we are going to have a historical description of this relationship, I think, in the talk to follow. And so here is a simple example of this relationship. So spinning into thread and weaving into cloth. And in 1733, John Kay mechanized the shuttle. And then in 1764, the spinning machine was invented. And so you had an enormous increase in productivity and a wider availability of goods and the lowering of the cost of the goods. But you also put spinners and weavers out of jobs. And this happens again and again and again through time. And it is the process by which apparently our state of happiness and well-being improves. And so you have this global relationship between research and development expenditure and the gross development product that we must understand. A GDP which does not include a definition of how sustainability and environmental effects should be accounted for, but certainly this relationship is important. And it's important to understand in the context of the amount of money governments spend on research and development. So there are three types of information in this graphics. So this is the research and development investment as a percentage of GDP on this axis. There is the number of scientists and engineers per million people on that axis. And the size of the circles gives you the absolute value of government investments into research and development. So you can see, given the previous slide on the relationship between GDP and research and development, a set of countries over here that invest significant amounts as a percentage of GDP, combined with a large number of scientists and engineers, the normalized set of scientists and engineers. India lies somewhere here, more or less at the bottom of the heap. The Chinese have invested enormously in recent years. This is 2010 data. And their investment in R&D has really outstripped the rest of the world. And so today, if you look at more recent numbers, and these numbers just give you a feel of the kind of money that goes into R&D investment. And that's important for you to understand and know. These are not insignificant numbers. 612 billion US dollars, 500 to 600 billion US dollars at purchasing power parity. And these are per capita values, and this is as a percentage of gross development product. So we are spending, governments are spending significant amounts of money into science and technology simply governed by this sort of understanding. So India at the bottom of the heap there, but nevertheless, we have spent significant amounts of effort into creating structures and science and technology that addresses key concerns of our time. So there is the Department of Atomic Energy, the Ocean Development, Science and Technology, Space, Biotechnology, Defense Research, and the Office of the Principal Scientific Advisor is a cabinet rank position. And of course, there have been people whose faces you may or may not recognize and names that you may or may not recognize that have contributed to the creation of this structure. We have also spent a significant amount in committing to higher education. So this may be slightly outdated, but the numbers, but 30 and 16 and 10 new institutes of science and technology and so on. And of course, the question one always asks is there adequate quality primary education to back this up? And so a number analysis of supply, demand, and availability would be a useful thing to have. And that, with that commitment, the graduates in science and technology, India is actually only second to China. 2.6 million per year, as compared to 4.7 million. And these are science, technology, engineering, mathematics graduates. But about 20 to 30% of the 1.5 million engineers that pass out every year run the risk of not getting jobs at all, as reported by the Economic Times. And we need to understand this as well. And so, just to conclude, I hope I've been able to impress upon you that science and technology are really woven into the fabric of our society. And there is a large-scale impact of technologies on society. And I hope I've told you why that is so and provide you a framework of why that is so. And therefore, choices about which technologies will be used and how, and a need to make decisions about the scale and directions of the way we use scarce resources, and the trajectory of those choices that determine our well-being and health, energy, water resources, clean air, things that Jay touched upon. But I do want to conclude by saying that these choices are too important to be left to scientists, technologies, and engineers. The socio-economic context of the relationship between science, technology, the economy, and society is too complex to be left to this group of people alone. And therefore, I want to conclude with the plea that all of you must get involved. You must get involved in understanding, analyzing these effects. These will affect the world that we are going to live in the future. And your understanding must be conveyed to the public in a way that only you will know best. So thank you very much. Happy to, I guess, answer any questions.
You mentioned about the management which the politicians should do in solving problems of society. It is not the scientist's job to go and fix a leaky water tap or electrifying the villages. That is a wonderful point. I just want to know what is your take on the policies which the governments are focusing on interdisciplinary, multidisciplinary research, which are more societal need-based rather than science for the sake of science. The story of US, NSF was created where fundamental science is let on its own devices. We fuel fundamental sciences, technology comes as an offshoot. But here, nowadays, if you look at the funding opportunities given by ACRB or wherever in India, people who have these reputation of running big groups, interdisciplinary groups, they only get the chance of even, considered for review. So there is a entire shift that if it is not useful for the society, we don't have to fund you. So that being the perspective, how do you take that? Science for the sake of doing science doesn't exist anymore because we don't have the whereabouts or the opportunities. So how is this shift to be, taken in and adapted by the younger generation? I think I made my point a little clear.
I think that shift does definitely exist. And I think we must understand that translational science and that translation into technology, and then creating the factors that will enable the technology to deliver goods and services that people want, is an extremely important component of our well-being. And therefore, a change in emphasis through government policy into translational research is important. And we are seeing the transition. And you're absolutely right that it affects a generation of scientists who are doing science for its own sake. But these are the pulls and tugs that exist in a developing society. And it is as it is, and you have to accept it and do the best you can, which is why I also talked about Gregor Mendel and his study on peas, and the enormous impact it has had decades and generations down the line into understanding what we are. I'll leave it at that. It's important, I think, in this context to understand that in this enormous science and technology population that we're churning out, there is a Gaussian of distribution and capability. And not everyone does science at the cutting edge of science. And it's important then to fund people who are capable of doing science at the cutting edge of science, rather than fund mediocre science. And so therefore the choice of funding and the way the funding is driven also matters in that context. Okay. Yeah.
Sir, my question is that how could we get involved in? How could most people get involved in scientific discoveries or technologies? Because most of the time, only the scientists who are working on something know the details about it, would have an inkling about the outcome of what they're working on. Even Gregor Mendel, when he was doing that, he wasn't even sure, even he wasn't sure the actual outcome of his experiment. He wasn't even experimenting, technically speaking. So how can we get involved in it? At the inception or during the process?
As future journalists, are you asking from the point of view of your profession?
As in general society, how could a politician know, yes, this is important for our society? So in that case,
so there are, I guess there are multiple roles that people play in translating what is going on in our research laboratories to the public. And certainly interpreting science and technology and the trajectory of policy is an extremely important task. And which is why we have CSTEP as an example of a think tank. And this is exactly what CSTEP does. It understands emerging sciences and technology, existing technologies. It understands the social and economic aspects of, for example, Jay talked about the transition to green energy. What will that entail in terms of social costs, in terms of economic costs? What are the right kinds of technologies that you use? And I believe there are government departments, a large number of them, as well as think tanks such as this. But this is for policymakers. Okay. The other aspect is the understanding of science and technology to the public at large. And I think the media has the most important role to play in that. And therefore, I mentioned your engagement, and of course, the media does many, many things, and I would, for one, hope that there would be a small segment of the population of emerging media and all of you that would say that my job as a journalist is to interpret science, technology, and the management of delivery of goods and services to the public. And if the question you're asking is, how do I get to do so? Well, my suggestion to Sashi was that we have an elective course in ACJ that will provide that opportunity of the process of doing so and how do you do so down the line. And that's for Malini, you're there, and Sashi's there, and Malini, I forgot to thank you for your help in putting this together, by the way. Yes, sorry, Malini, and for her administrative support, I apologize for that. So yeah, I guess that's the best answer I can give you at this point in time.
Basically, as a journalist, I interviewed the director of IIT Delhi
Yeah.
5 years ago for the Hindu.
Okay.
And on record, the director said that one of the greatest problems of IIT
Yeah.
is that after their BTech, students want to, begin startups and all. And he said the focus on research. Now, this is as just 5 years ago. Maybe there's an improvement now, but he said the focus on research is not really there, due to which the kind of excellence that could be produced is not produced. So what do you have to say about that? They in fact even said that IITs should focus on PhDs and leave the BTechs to NITs. So would you like to comment on that?
No, well, first of all, the issue of employment, I mean, you can focus, you can certainly have a focus on research, and you can produce people with master's degrees and PhDs and so on. And the IITs have transitioned from being an essentially undergraduate teaching institution to a situation where the number of PhDs and master's degrees actually equal the number of undergraduate degrees that the IITs produce. The real question is the employability, okay? And we think of employability in two sectors. One is the government sector. So the government sector in its departments of space and defense research and atomic energy has a real continuous need of high quality master's and PhD students. But that is nowhere near enough in terms of employability of the numbers of PhDs that we are producing today. And the idea of doing that, and this transition actually came through a report by the Anil Kakodkar Committee, who was the Secretary of Department of Atomic Energy, and he said that IITs must transit towards research. The anticipation was that industry in India would grow to be innovative enough to require high quality technology support from our own engineering graduates. You have to think of this ecosystem of industry in India. How much of that industry is actually obtaining mature technologies from elsewhere that then transitions into production? How much of industry is actually using inbuilt innovative technology? And the economics and costs of these two things. And the situation today is that industry in India is still not innovative enough to demand its own Indian cater of science and technology. And therefore, the employment opportunities for people with a high level of qualifications continues to be relatively low. So my perception in a direct answer to your question is that we hope in the future the growth of industry in India to be truly competitive will also demand the output of science and technology that the country is capable of producing. I don't want to distinguish between organizations which just does undergraduate teaching and just does research. For me personally, the two must be combined, because what I as a researcher can bring to undergraduate teaching is much more than the guy who doesn't do research, in terms of my experience and so on. Yeah.
So one question, that you said that the choices of trajectory, direction, and about which technology to use should be in the hands of the common people.
No, I didn't say that. I said you need to have an interdisciplinary grouping of social scientists, economists, scientists and technologists to together determine that trajectory, because all those inputs must come together to determine that trajectory. I did not say it must be in the hands of common people. Okay?
Understood that, but
Yeah.
the second thing is, can you briefly explain the pea experiment on the discovery of the inheritance using the pea plant? Can you talk about that a bit more? That was interesting.
Gregor Mendel's life is well, no, I'm not going to talk about that because I've read a bit about his life, but that was long back, and I don't want to give you information that I don't remember well. But I think this evening or this afternoon, when there's a talk on health sciences, I suspect that's the person to ask. Okay, I just wanted to provide an introduction to the topic that will come this afternoon, and you might ask that person. Incidentally, he worked in a monastery, that I remember, and he struggled enormously to do this research in the environment that he was in. But,
Sir,
yeah.
sir,
Yeah.
I want to ask sir, we have IITs, but IITs are not enough to, everybody can't go to IIT. So I see that, what about the quality of science education in India? Because we see when the job of a clerk, right, there are a lot of science graduates applies. We see that they're not getting employment, like you're talking about the employability. So we have IIT, but what about other institutions in a tier 2 cities or tier 3 cities?
You're absolutely right that the quality of engineering education drops off very steeply as you go from the IITs to then, the IITs and then IITs and then various colleges. There are a number of extremely good private colleges that are emerging. I think we have nowhere near the quantity of quality engineering, science and technology engineering education that should be available. The distinction between a person who gets into IIT and doesn't get into IIT is often something like 0.25% in an entrance exam, which means nothing at all in relation to the capability of its people. And really, none of us should struggle that hard to get a good quality education. Okay? That's a matter of principle. In practice, and the government has therefore grown the number of IITs, and it has increased the number of students the student intake into IITs. But ultimately, here comes the economics of providing good education. And so you have to ask whether we are spending enough on education. At all levels, it's not enough, and I mentioned this, it's not enough to create higher education, quality higher education. The feeder into that higher education comes from our primary and high school education. We have to struggle with the problem of providing quality education, not just in English, but in languages throughout India that people grow up with. And I think the evolution of information technology into quick translation from English into all our languages should help enormously in that regard. The delivery of knowledge itself, given the lack of teachers through various aspects of information technology, should aid the process enormously. So these are some of the things that I think should provide a cornerstone of our education policy. Certainly the use of emerging information technology and language translation capability should increase the general literacy level in our country in ways that we must engineer. And I think that's an important concept. Yeah.
Hello.
Yeah.
Hi, good morning. So I know that, all these great scientists and physicists, they all believe in religion and God. But isn't that something contrary to science as a subject? So I'd like to speak upon that.
I did mention right at the beginning of my talk that both science and religion essentially explore our concept of ourselves in the world. So they have a common purpose. The approach is different, okay, in the two cases. Sir Isaac Newton, by the way, in relation to your comment, he was an alchemist. He believed in alchemy, and he actually practiced alchemy. And so, yes, it appears to be contradictory, but people, I think, take different approaches to understanding ourselves and our world. And given the scientific notion that there are no absolute truths, I don't even want to say that one approach is not better than the other or
worse than the other. I think it depends on us as individuals and our bent of mind and our approaches to this understanding. Okay, I don't think they're contradictory. They could be contradictory. They need not be contradictory. It's pretty complex, that.
So institutional science, whether it's through science journals or universities, has rather dominated what gets to be science and therefore what gets to be knowledge. At the same time, we have, we're also seeing that there's increasingly talk about how indigenous peoples have always had their own ways of knowledge, especially if we look at the life sciences or...
Sure.
Yeah. So so you talked about opening up at least the interpretation, opening up the interpretation of science to more people who are outside of these institutions. So for example, citizens also, whether it's from social sciences or economics and all of that. Are we also looking at production of science from spaces outside of these institutions?
I don't want to distinguish between knowledge that's created in an institutional setup and the knowledge that is based on decades of experience. Okay, Ayurvedic treatments is a classic example. I mean, and I'm sure we all understand that Ayurvedic treatments, like allopathic treatments, have their advantages and disadvantages. But that is also knowledge which is based on decades of experience. What has not happened is the attempt to understand the efficacy and efficiency of those treatments in a way that scientists subject their conclusions to. Okay? And that does not seem to have happened. And so if you really want to understand the efficacy of various treatments of disease, whether they be tribal or indigenous or Ayurvedic or allopathic, it's important to collect data on the efficacy of those treatments. And some of you who've been following the COVID news will understand how difficult it is to collect adequate statistical data and follow up. This takes years, and populations large enough to provide reasonable statistical information. So unless those communities and their treatments are subjected to the same statistical evaluation methods of their treatments on large populations, we will not see the growth of those kinds of treatments. Okay? I mean, unless you can confidently say that this Ayurvedic cure for jaundice has cured 80% of the people that it has addressed, you will not accept that sort of treatment. And that's the bottom line of what I was trying to say. Okay?
All right. I'm sure there are many more questions, but in the interest of time, I think we'll close this session here. But keep your questions, and Dipankar will be with us through the day. Without asking him his permission, you're free to ambush him wherever you see him with your questions outside of this forum while he's here with us today. And also there's in the culminating session, it's an open session where some of the questions which are relevant to any of the talks that took place here could be raised. So we'll move on to the next speaker before we break for the morning session. Yes, thank you so much. Thank you, Dipankar, for that very fascinating talk, and I think in the question and answer session too, a lot of ground was covered. And now it's my pleasure to introduce to you our next speaker, Dr. Aparajit Ramnath. Dr. Aparajit Ramnath is Associate Professor in the Humanities and Languages Division at the School of Arts and Sciences, Ahmedabad University. He is a historian of science, technology, and business in South Asia. He is the author of The Birth of an Indian Profession, Engineers, Industry and the State, 1900 to 1947, published by Oxford University Press in 2017. And is working on a second book, which is a study of the engineer and public intellectual Sir M. Vishwesharaya. Aparajit also writes for non-specialist audiences. His articles have appeared in The Hindu, Scroll, The Wire, 52.in and other publications. Aparajit was educated at BITS Pilani, Oxford University and Imperial College, London. He has been an international scholar of the Society for the History of Technology, a Sangam House Writing Fellow, and a winner of the Indian National Science Academy's Young Historian of Science Award 2018. So he's come all the way from Ahmedabad. Thank you very much. I might also mention finally that his sister, Shreya Ramnath, was a student of this college and then went on to teach in this college before she pursued, I think she's either doing or finishing a PhD somewhere now as I speak. Thank you very much, Parajit, and over to you.
Is it working? Can you hear me? Yeah. Okay. Thank you so much, Professor Sashimenon, Professor Nalini Rajan, Dr. Jay Asundi, and everyone here who has, thought to invite me and who has made it already a very pleasant and enriching experience. I have a very difficult task before me because Professor Banerjee has given a wonderfully erudite talk, which also covers a lot of aspects of the historical and philosophical understanding of science and technology, which to some extent I was hoping to talk about, but I will reiterate some of those points. And also because some of your questions were so insightful that they brought to the fore so many interesting points, which I think I would like to touch upon in some cases where they intersect with what I want to say today. Okay. So I'm an interloper. Obviously, I'm not a practicing scientist. In a previous life, I was an engineering student. I escaped that life because I landed in it wrongly. But something from that stayed with me, some interest, at least tangentially, in science and technology. And that has taken me into the field of the history of science and tech. And so what I'm going to talk about today is some insights that we can draw from the study of history on the relationship between science tech on one hand and society on the other. And those insights are going to come from two sources. One is some snippets from things that I have personally been involved in researching, and the other is the broader work that is out there, the rich literature on science, technology, and society, which of course uses plenty of historical examples, but also draws very liberally from other disciplinary approaches like sociology, anthropology, philosophy, and economics. Okay, so let me start with one snippet, which is based on some research that I did a few years ago and an article that I just wrote for The Hindu a couple of weeks ago when the Howrah Bridge, which all of you know about, in Kolkata, reached its 80th anniversary of its opening. Right? So this is a familiar form. This is a very spectacular a bridge. It was, when it was opened, the third largest cantilever bridge in the world. A cantilever bridge being a bridge with these two arms coming together from the sides without any piers supporting it in the water, without any suspension cables, etc. So it's a considerable engineering feat when it was opened in 1943. And most accounts of it have focused on these the aspects of its design, the engineering know-how that went into it, the companies that supplied steel for it. Tata Iron and Steel supplied most of the steel, which was a particularly important high-grade steel, and so on. But I want to delve a little deeper into the story and talk about some of the other factors that went into the making of it. Okay, so we start our story in 1874 when a bridge is first built between Calcutta, as it then was, the first city of Britain's Indian Empire, and a big commercial center. And on the other side, Howrah, which is the terminus of the East India Railway, and therefore the gateway to the rest of the subcontinent. And so this is a very, very important crossing commercially. And it is, earlier people used to have to use the ferry, and in 1874, a British engineer called Bradford Leslie designed and erected this floating bridge. So a floating bridge, as you can see, is a bridge that rests on pontoons, which are like little boats, which are themselves floating on the surface of the water, and then you have the bridge slung across them. The bridge had an opening span in the center, so that meant that at certain times of the day, that span would be floated away so that ships going from the Calcutta docks upstream could pass, and then it would be put back. But then that meant the traffic was disrupted. Of course, at this time, it was largely bullock carts and things. But later, there was a need for a more permanent solution. And this bridge lasted for, it was meant to last for 25 years. Its replacement got delayed by World War I. By the time World War I was drawing to a close, the government of Bengal was very, it had to act fast. And at this time, Bradford Leslie, who was by now a 90-year-old, came up with an alternative, or rather, he came up with a design for a new bridge, which would be a twin floating bridge, that is, two floating bridges like this next to each other. But it was rejected for various reasons, and the government set up a committee of engineers under the chairmanship of someone called Rajendranath Mukherjee, who was a famous engineer come contractor whose company, Martin and Company, was among, they did many iconic Calcutta projects, including the Victoria Memorial. Right? So this engineers committee, which had people from the Public Works Department, from railways, and from the irrigation department, etc., they looked at various kinds of possible bridge designs, right? So some of these bridge designs were a single span arch bridge, a suspension bridge which uses cables, a pier and girder bridge, and the floating bridge option put forward by Bradford Leslie, and then a cantilever bridge. All right? So you can see here that they all use different principles, and they're going to have different impacts on the soil and the surrounding area. So lots of details were gone into the fact that it is a seismic zone, the fact that the flow of the river should not be impeded because it would then spoil the functioning of the docks. So pier and girder was ruled out. And then there was a particular kind of alluvial soil in the Hooghly Basin. So keeping all of this in mind, the ultimate recommendation was for a cantilever bridge. Okay, it was also easier to maintain because it doesn't kind of go into the water so much. And ultimately, this was the recommendation. But there was a catch. The cantilever bridge, as you can see, was among the more expensive options. Okay, and when it finally boiled down to a choice between the floating bridge and the cantilever bridge, and then when the government of Bengal floated a bill in the Legislative Assembly saying that we are going to raise money for this cantilever bridge by taxing businesses. So they would tax people using the ferry and the railway that came into Howrah. They would tax goods coming in, and they would tax the municipalities that stood to benefit from this, and so on. And when they said this, they immediately met with opposition. There were multiple stakeholders. There was, of course, an engineering debate with people like Bradford Leslie and others who were talking about the relative merits of these two designs. But there were also other actors like the business associations, the Calcutta Chamber of Commerce, the Marwadi Association, the Calcutta Corporation, and municipal leaders. This was a very crucial stage in Indian history. This is the early 1920s when constitutional reforms have allowed Congress leaders and other Indian politicians to come into the legislative assemblies and the corporations in much larger numbers and more significant positions than they earlier had. Okay, so they're able to raise questions, and they're worried about their constituents because if the taxes going to increase, they don't want that to happen, and they are ranging themselves against more colonial British-dominated bodies like the Improvement Trusts, which existed in most British Indian cities. And there was a vigorous debate in the Bengal Legislative Assembly where they're talking about, is this just a lavish sort of paean to British imperialism? Why do you want to build this extremely costly bridge? Why don't you just have, why don't you just repair the old bridge, or why don't you use the floating bridge, etc. Now, so long and so detailed was this debate, it stretched over many, many years, that ultimately it was only in 1933 that a decision was taken to go with a cantilever bridge. And even then, it was only made possible by the fact that the consulting engineers who prepared the design finally made some adjustments to the design and brought down the cost, the proposed cost, radically. All right. So, to cut a long story short, this is of course the final form, and this is a good example of how a project that's that we think of as primarily technical and engineering, its shape, its design, many of its characteristics, many of the parameters that are finally accepted, the timing of its acceptance, all of these are working in conjunction with economic and political considerations. And it's not just a question of which is the better or the more correct design, right? There's no such thing. There's so many other factors that go into it. And so this is just a small story to illustrate this, this point. Okay, so that's the first insight, which is which I want to highlight today, which is that science and technology are deeply influenced by the social and political context in which they develop. Of course, this argument can be extended in many ways. Even when we talk about science, scientific ideas, scientific theories, we talk about them being socially constructed. In other words, they're not just true ideas out there in space to be plucked out and plonked into a journal, but they come with in certain forms which reflect the institutional arrangements of the scientists, the social backgrounds, the societies from which they come, the political situation in which they function, and so on. And famously, science and technology are seen as handmaidens of imperialism, right? Colonial expansion from Europe had a very important relationship with the growth of modern science and technology as we know it. That's not to say that science and technology is necessarily evil, but we must keep in mind these contexts to any particular technology or scientific theory when we go ahead. Here's another snippet. This is Sir M. Visvesvaraya, about whom I'm writing currently, as you heard. He spent 25 years as a public works engineer working on various irrigation projects in the Bombay Presidency before he became chief engineer and then Diwan of Mysore. And that's the part that he's more known for, his role in the creation of a modern state of Mysore, and then his role as a public intellectual later. He became a big advocate of planning, economic planning. Even before Mahalanobis came on the scene, he was president of the Indian Economic Association in the 1920s for one of its meetings, and so on. So, but what's interesting about his ideas on irrigation is that he internalized the colonial philosophy of irrigation projects so thoroughly that he even went a step further. And I'll tell you very briefly how he did this. The late 19th century saw a great flowering of large dam and canal projects across India, especially the northern part, where the Ganges Canal in the mid-19th century. Then you had in Sindh the various new agrarian settlements that were created with canal projects on the Indus. And these were very consciously social engineering projects, right? They were created to settle nomadic peoples. They were created to make them governable subjects. They were created to increase food production and reduce certain political problems, in part. Now, there was a distinction between two kinds of irrigation, which is known as protective and productive irrigation. Famine was the specter that stalked India in the 19th and early 20th century. And protective irrigation referred to the kinds of projects which were required to make sure that people could grow some basic food crops even in the absence of rainfall. Whereas productive irrigation was that which was meant to help you grow cash crops, right? To produce stuff that you could then sell in the market and produce more income. Now, Visvesvaraya was someone who, who said that the best protection is productive irrigation, right? So even if you have a famine, if you grow expensive crops, you can sell it somewhere else and you can buy food. So he kind of took this logic to its extreme, and this influenced a particular scheme of irrigation that he implemented near Pune on the Neera Canal called the block system of irrigation. And it's perhaps not a coincidence that that area even today has grown into a very, very important area in terms of sugar production, right? Sugarcane, the growing of sugarcane and paddy was kind of his goal. And he did the same with the famous Krishnarajasagar Dam near Mysore, which was initiated under his chief engineership in 1911. Of course, it took another 2 decades to build and implement fully. But if you go to Mandya district, which is the area served by these canals, you can see within 2 generations, what a change it has made to people's lifestyle, right? It's made them prosperous. It's again become a sugar producing hub, and it's changed the profile of crops that are grown. Visvesvaraya is worshipped as a kind of god there, and Annadatta, right? So there is there is a very particular kind of effect that some of these projects have on society, and in fact, these aims are very much built into these into the projects, and they are part of a larger vision of an industrial, commercially thriving society that engineers like Visvesvaraya had. Okay, so science and technology impact society in profound ways. Here's another example, a classic example of the Industrial Revolution, the steam engine. You have the steam engine becoming, of course, we think of it as coming with James Watt, but it's not until it becomes an engineering possibility to replicate it on a large scale that it really becomes influential. And then it allows you to go away from water power, and it allows you to set up factories in other parts and concentrate them in cities. This leads to the growth of places like London and Manchester. It leads to urbanization. It leads to the growth of slums. It leads to a lot of human rights issues, which took many, many decades to be addressed later on, right? So science and tech obviously has a deep impact on society. But while they impact society, they are not autonomous forces. Now, we have this strong tendency to view them as having some kind of internal logic. This is Lynn White, a medieval historian, and he's famous for a thesis he put forward, which is that the coming of the metal stirrup, which you see on the right, led to the rise of feudal society in certain parts of Europe. Okay, and he had this plausible-sounding argument that once the stirrup was in place, it increased the efficacy of horseback warfare because people were not falling off so often, and then that required certain kinds of arms and weaponry and armory, and then in order to do that, you needed a capitalist mode of production, and then so on and so forth, and it led to feudalism. All right. Now, of course, I'm caricaturing his views a little bit, but they have been questioned, they have been refuted on various bases, and they now serve as the classic example of what we call technological determinism. Another example is Moore's law, which people were very excited about, at least when I was an engineering student. Some of you may have heard of it. This is G.E. Moore, who was one of the founders of Intel. And he said in 1965 in a popular article that the number of transistors on a chip will double every year. And then he changed it to 2 years and so on. And this was cited as some kind of law of nature for a long, long time. Of course, it held more or less true, but that's another matter, right? The fact is that we are thinking in these instances of technology as something that has a logic of its own, an internal logic, something that is bound to go in certain directions, and that all we can do is to react to it. How do we cope with AI? How do we, how do we make sure that we are not overrun, right? And this doesn't account for the fact, or it de-emphasizes the fact that it is we, it is society that decides, or human actors that decides how technologies develop. And this is something that the speaker before has eloquently talked about, but I'll return to it in certain ways. Okay, I just want to do a quick poll among the students. Which of these would you call a technology? You can just shout out the answer. The smartphone, all right. Anyone else? The bullock cart? Anyone else? The communication towers. So we have the horse left. Who thinks the horse is a technology? Okay. The point I'm trying to make here is, of course, as Professor Sashi said at the beginning, when we talk about technology today, we almost inevitably mean these gizmos and gadgets and communication technologies, our smartphones, our computers, the internet, etc. But technology is actually a very, very broad category. Technology can be defined in many different ways, and it's a very tricky term, because if you think of technology in analogy with something like biology, right? What is biology? Biology is the study of living organisms. By analogy, technology should be the study of techniques, the study of machinery, which is what it meant for a long time, before it came to mean the thing itself, the thing that you use, right? So it has many different registers, but in a sense, it's referring to a thing or a concept or a branch of study which is related to our making our lives easier, to achieving a certain purpose. And in that sense, a horse which is bred for a particular purpose might also be seen as a technology. Sometimes it becomes a part of a technology. Horses played a very, very important part, historians have shown, not only in World War I, but also in World War II, which was considered to be a battle of tanks and aeroplanes and other things, right? Again, when we think of technology, the historian David Edgerton has shown in his book, The Shock of the Old, if you ask somebody what were the iconic technologies of the 20th century, they're likely to say the rocket, the aeroplane, the internet, the computer, all right? But if you ask a different question, what are the most ubiquitous technologies? What are the technologies which have had the most impact on people around the world, on poor people around the world? Your answers might be very different. It might be corrugated iron roofing, which build the favelas of Rio or the shanty towns of Dharavi, etc. It could be many other very simple everyday technologies, in the words of another historian, David Arnold, who talks about sewing machines, bicycles, typewriters, rice mills, okay, as being critical to the making of India's modernity in the 19th and 20th centuries. When we concentrate on the big, we miss out on some very important and useful and interesting things in the world of science and technology. When we concentrate on innovation or invention as a synonym for technology and science, then we're obscuring a large part of what is the world of science and technology. And that is David Edgerton's point, right? The conflation, as he calls it, of innovation with technology is dangerous, because then we don't talk about use, we don't talk about maintenance, we don't talk about repair, we don't talk about the uses to which existing technologies are put, which also was spoken about a little bit earlier, the translational aspect of science and technology. Okay, so science and tech are not necessarily about what is big and what is new. So I would go so far as to say that, as journalists, we are attracted sometimes to some of these big, spectacular stories, but do keep your antenna sort of, I don't know if this is the right metaphor, but keep them alive to look at other things which we might not think of normally as science and technology, but which might actually be really impactful in many ways. Here is Robert Moses, who was a hugely influential figure in the building of modern New York City, and the subject of a doorstopper of a biography by Robert Caro. And in that biography, Caro said something about Moses, which got picked up by the political scientist Langdon Winner when he wrote his article called, I think, Do Artifacts Have Politics? No. Anyway, I'll get back to you on the exact article. But Langdon Winner is picking up this example, and this is one of the bridges leading to a parkway in upstate New York. And the story goes that Robert Moses created these bridges at a relatively low height in order to keep public transport like buses out of the beaches that he built for the wealthy or upper middle class New York citizenry, and that also translated into a kind of racial segregation, right? So this was, and of course, people have argued that he didn't really intend this and so on, but the point remains that it's possible to conceive of such a thing, and there are other examples as well. Here is Baron Haussmann, who redesigned the city of Paris in the mid-19th century. And this is one of the boulevards that was created in 1855. And the date is not a coincidence, because he was commissioned to do this by Napoleon III soon after the uprisings of 1848. And the uprisings of 1848 happened very often in the narrow medieval streets where people could put barricades and create sort of disturbances and so on. And so the point of this these new vistas was to reduce the chance of political revolution, right? So technologies are not apolitical. And just as a small sort of follow-up to that, technocratic solutions are not an alternative to political engagement. Technologies can help. Technologies can help us solve problems. Science and technology is very, very important, obviously. We must use them. We must use their benefits. We must harness their abilities. But as the previous discussion showed, when Professor Banerjee said, you must get involved, I think what it means is that there must be political discussion about these things, about the costs and benefits, about which sections are benefiting from a particular technology, what are the possible misuses of it, right? And these are things that societies must engage in and cannot leave purely to a small group of people. Having said that, I do want to mention that we are at a juncture where it's important to have a very fine balance between recognizing that science and technology are things that are socially constructed and that they must be subject to democratic debate and so on. But at the same time, we must not throw out the concept of expertise. And there's a tendency to do that in some circles today, with the rise of right-wing populism, with the rise of questioning of even basic things like the fact that climate change is occurring. And so we need to figure out as a society how experts, or how and when to defer to experts, and how and when to subject them to scrutiny. And that is going to be one of the most important challenges for the media, for journalists going forward. How to maintain this thing called the scientific temper, this idea of skepticism, this idea of being open to new approaches, while at the same time not falling prey to what we call scientism, which is to say that there's a narrowly mechanical view of how the world works. Somebody talked about indigenous knowledge. I think that's an excellent point. That's going to be one of the other new things that we look at when we look at science and technology. And I've written about this in the past. There is some evidence to say that what gets called science is, to a large extent, a reflection of historical power arrangements. Having said that, when we want to open ourselves to other branches of knowledge, we need to find ways of validating and verifying that knowledge. As Sir mentioned, you have, for example, clinical trials conducted on various materia medica that are available in particular populations. But there's another thing, which is that I think, and this is my personal view, if a branch of knowledge which has a long history and has some proven efficacy would like to be a part of the global scientific conversation, it's not enough to prove the efficacy, but that openness to critique must also be there, right? So there must be some way of doing what mainstream science does in the sense of peer review and publication, and then being open to being refuted, like Karl Popper said, right? If you're not falsifiable, your theory is not a scientific theory. So that's another challenge. How do you integrate these different streams of knowledge? The one that comes from this so-called Western scientific revolution, although of course we know it takes in streams from ancient India and China and medieval Middle East and so on the one hand, and the other, indigenous knowledges which are confined to particular groups of people who are endogamous, who live in harmony with nature, but without being exposed to the larger world on an everyday basis. Finally, I would say, as a historian, I would say historicizing any story can really help the audience, right? Because we know that we all love stories, but the very fact of chronology, the very fact of going back in time and saying how something started appeals to something in us and helps us to understand things very much better. So if you're reporting on something, try to include somewhere, unless it's obviously a very, very well-known story, do try to include some of the background of where these ideas came from, where these thoughts came from, and so on. Okay, so here's a quick summary of what I've spoken about. Science and tech can impact society profoundly, but they are not autonomous forces. We need to engage with them. They are deeply influenced by the social context. They're not only about what is new and big. And finally, technocratic solutions are not an alternative to political engagement. We need to use technology, but we need to also participate in the debates and discussions around them. Thank you very much.
Sir, but isn't it true that the political nature of technology and particularly scientific research has had a negative effect on it? Like, for example, in the 50s, through the 50s, from everything from smoking to sugar, and recently climate change, global warming, all the things that oppose the negative effects of these things have come from lobbyists, particularly in America, who propped up scientific researchers that said these things don't exist, they're not bad. And back then, for smoking and sugar, only when the negative effects were apparent in society were the things actually banned. Lead in gasoline, that's one example. Yeah. And even Robert Moses, who was so powerful, he hated poor people. He hated women and children.
That's
and so
my point.
So when he created the roads, he made sure that the roads went through poor districts and families, so they had to be displaced.
Yes.
So in this case, that was not efficient. Actually, the New York road system is extremely inefficient because of that. So all these things, the political nature of which influence this technology and science, isn't that a negative thing most of the time?
I think I would use your very examples to reinforce what I'm saying. I think we are just talking about the same thing, but with different terms. I'm saying precisely what you are, which is that, see, if we were not to politically engage with issues like smoking or climate change, etc., and say that, look, so-and-so journal has published a study, or so-and-so scientists have said this, let's not question it, then you have the possibility of funders distorting science. You have the possibility of vested interests coming into play. So when I say political engagement, I mean that people like us need to ask questions of institutions, right? We need to ask what is the purpose behind it? What is the context behind this? Is it something that is, does it pass certain tests of verifiability, validity, and so on? Of course, in many cases, only fellow scientists would be qualified to do that, but in many cases we can do some basic verification as humans. You talked about Robert Moses, that was precisely my point. My point is that technology, very often, when we dream of a utopia where some highly educated people can produce technological magic solutions for the housing crisis, etc., we don't realize that sometimes these kinds of political assumptions may be embedded behind those solutions. Therefore, the solution is not to do away with science and technology. The solution is to subject them to the same kind of scrutiny. That's what I'm saying.
I just want to know what is your view on this. Science and technology are not necessarily about the big, you made a statement. If you can shed a little more light on that, as well as on the point which you mentioned about David Edgerton saying innovation alone is not technology, something which is not very clear to me. The reason why I'm asking is now there is a huge impetus in our country to do this innovation. So what could that be in our context? So these are the 2 points.
Sure, thank you. I'll start from the second one. So I think the point that Edgerton is trying to make is that, see, what is your end goal? Your end goal could be many different things. Let's assume here we are talking about policy. So our end goal is to increase the standard of living, or to solve certain problems, or to increase the quality of life, etc. Right? Now, if you have 2 possible solutions, one involves a more efficient, better use of something that already exists, and another to create something completely new because it sounds fancy to say that you've come up with something new, which is more efficient, right? Or which would you prefer? That's a simplified sort of solution. What I'm trying to say is that, yes, innovation is important. Generation of new ideas is important. But it shouldn't become an end in itself. It shouldn't become a kind of a fad, right? Where you say that you do something new just for the sake of it. And very often, what he's saying is the most impactful thing. I mean, look at this microphone we're using. It's been around for 100 years or more. The chair you're sitting on has been around for thousands of years. Not that particular chair, I hope, but as a concept. And so those are the things that make up the majority of our lives. And we mustn't make them invisible, right? Sometimes we need to spend some more time on how those things are allocated. Again, this is not against innovation. It's about bringing back a sense of proportion to our discussion. The other point you made about big and small technologies, again, very much related to that. So what I'm saying is that let's broaden our view of what is a technology, right? Think of something like the invention of Braille, right? It's not fancy, it's not shiny, it's not somebody going to the moon, but it changed the lives of millions forever and ever. That's a technology. Writing is a technology, right? So it's just an observation. Yeah.
Was because nowadays when students, either journalists or science students, they are attracted towards the fancy discoveries happening. So were you trying to say that, look for small things like tabletop science, which can be, revolutionary? So that was the context in which I was asking.
Absolutely, yes, please. I think that I would personally love to read more about those kinds of things as well. Yeah.
Sir, is all science and tech purpose-driven? Is it driven by social and political reasons only? Because some inventions are accidental as well.
Yes.
So what is your take on this?
Yes, of course. And then you have the idea of basic research where you're doing something for knowledge's sake, right? But even then, that what I was trying to make, the point I was trying to make is that it is socially conditioned to the extent that you are operating in an environment, right? You are in a lab which exists with some prior assumption. Why would somebody fund that lab? Or why would society subsidize you to do a certain thing? Because there is some expectation of what you're working on and what it might lead to, right? Unless you are a moneyed gentleman of science in Victorian England, which some people were, like Darwin. But even Darwin was able to go to the Galapagos Islands because he joined an imperial expedition, right? On his own, he wouldn't have been able to go. So yes, there is a room for serendipity in science. There is room for unexpected consequences. There is room for exploring knowledge for its own sake. But it still occurs within a certain context. And there are other types of science and technology which are undertaken for explicitly political ends. Not all.
So in your talk, you asked a question that which is the technology which has changed the life of people in general. And I want to answer that one of these technologies is the digital payments, which I see it's remarkable in India in terms of a small vegetable vendors to a shopping mall. Everybody uses digital payment. It's remarkable. So I want to ask a question, where you see India is positioning right now in terms of technology. We have the example of digital payment, which is India is like remarkably way ahead of even the developed countries. And then we have those things like COVID app. In the times of COVID, we see how it helped people to actually get vaccinated in the people. So how you see India's position right now in terms of technology and contribution to the world?
That's not an answer which I'm really qualified to answer, other than as a general sort of citizen and consumer of news. I don't consume as much news as I should, but I think I would maybe I would ask you to think why you're framing that question in that particular way, because does it matter where India stands in the rank of nations in terms of producing apps, etc.? We should be worried about, are we able to solve our problems? Yes, those examples are excellent cases of being able to solve certain problems, but do we need an accolade, therefore, to say that we are ahead of so-and-so country in this kind of technology, or that we are ahead of the US in terms of online payments? I mean, that's not terribly relevant in my mind. Sorry, I mean, I don't mean this as a criticism, but it's just a question.
You said that technology is used as a political tool, so it's also used as a geopolitical tool. So my question is in regards to that.
Oh, absolutely. I mean, look at the Cold War, right? Yeah. Look at what happens in the Cold War. Almost everything that is pushed at that time has some kind of connection to the relative standing of the capitalist and communist worlds, right? They're trying to prove that one is the better system or the other. We talked about, Professor Banerjee talked about the funding of various kinds of technology, and Eisenhower spoke in 1961 about the military-industrial complex, right? So there's absolutely no doubt that science and technology is very often coming out of a certain geopolitical context of competition, of strategic concerns, etc. But then we must also recognize that there are lots of very peaceful and otherwise good uses that come out of those, that have come out of those things historically. Thank you.